Hello, everybody. Welcome to your last video lesson. We were working on finding solutions to polynomial functions, and up until this point, we've been able to find those solutions by factoring. All right. In your last lesson, I had you practice factoring the sum and difference of cubes. Okay. So today, we're going to take that one step farther. And how do I find the solutions once I do that first step of factoring? All right. So since these problems, we're not going to be able to factor the quadratic part that we got when we factored the first time, that means we're going to have to use our quadratic formula. All right. So if you recall, we have our quadratic formula, I have it written here. So x equals the opposite of b plus or minus b squared minus 4ac, all divided by 2a. All right. So if I have what we call the complex solutions with our imaginary numbers, those are we'll be able to find those when we do our quadratic formula. All right. So what I'm going to do is I'm going to take two problems that were from the homework last time. So you already did step one, and that was to factor using your perfect cubes. And then we'll go ahead and work through and find our solutions. All right. So the first one I have here was number 10 from your homework. So we have x to the third plus 64 equals 0. So on your homework, you should have factored that using the pattern that I talked about for the cubes. My first factor here is the x plus 4. And again, that came from 4 times 4 times 4 is 64. So again, that's kind of how that worked in our pattern. The other part that we have here, this is the quadratic part that, again, we would try to factor again if possible. Okay, so we've got x squared minus 4x plus 16. And again, I would always look at this to see if you can factor it using our regular methods. However, you can't, okay? So there are no factors of 16 that would be able to give me that middle term of a -4. All right, so I always kind of look at that first because it would be faster if I could factor that. But since I can't, that means that I do have to use my quadratic formula. All right. This first part here, we can go ahead and find our solution right away for this. Again, we set each factor equal to 0. So I'm going to say x plus 4 equals 0. So I do have one real solution, and my one real solution would be at x equals -4. Okay. To factor this part here, again, this is where we're going to do our quadratic formula. All right, I'm going to go ahead and put a 1 in front of my x squared. So as far as my formula, again, this is the A, okay, this is the B, and this is the C. All right, then from there, again, we're just going to plug them into our quadratic formula and then do a little work on our calculator. All right, so I've got x equals, we need the opposite of B. So this B says -4, so the opposite of that would be +4, plus or minus. All right, we need the square root of our b, which is -4 squared, minus 4 times a, which is 1, times c, which is 16. And all of that will be divided by 2 times 1. All right. So in your calculator, we're going to go ahead and enter what we call the discriminants. That means everything underneath the radical. I'm going to put that into my calculator. And again, when you do enter this part, make sure you do have parentheses around the -4 because most calculators, you need that. So I've got -4 squared minus 4 times 1 times 16. All right, and that will give me a -48. All right, and all of that is going to be over 2. All right, now again, this is why we have a complex solution or imaginary, because if you look right now, I can't take the square root of a -48. You can try punching on your calculator. Again, you'll get that error message because it's not a real number. All right, so we do need to at least simplify and get rid of that negative sign from underneath the radical. Okay, so if we simplify that, we can write it at least like 4 plus or minus. I bring the I out in front, square root of 48 over 2. Okay, so you do need to at least simplify and bring the I out. Again, put the I in front of the square root. I've seen some of you writing it after, and then it kind of looks like it's still underneath the square root symbol. So please bring the I out in front. All right. Now, since 48 isn't that large of a number, I would kind of ask that you try to simplify that. And again, what I mean by that is, do you notice any perfect squares in 48? So when I look at 48, I definitely think of 4. 4 is a perfect square. I might try something like that. I might also see if 48 can be divided by 16. Let me check. All right, and it can. So again, to simplify, I'm asking you to look for perfect squares that you recognize as factors. All right, so 48, I'm gonna write it over here on the side for a second, would be the same thing as 16, okay, times 3. All right, my 16 is my perfect square. All right, so if I want to do a little more simplifying with the radical, okay, I've got 4 plus or minus. The square root of 16 is 4. So I'm going to bring the 4 out in front. I have the I out in front there. And then I would have the square root of 3 all over 2. Okay. And if I wanted to make it look really good, I would simplify this one more tiny little step here. Both of these are even and they're both being divided by 2. So if I want to make it look really nice, 4 divided by 2 would be 2 plus or minus 2i square roots of 3. And that would be your answer in simplest form. All right. Okay. Now again, so our solutions, we had one real solution. This would give me 2 imaginary or complex solutions. And again, which should make sense according to what we've been talking about. This was a 3rd degree polynomial, and it should have 3 solutions. 1, and then we get 2 that are imaginary. All right, so that was number 10 from the previous homework. This one, we're going to do one more here. This one is number 18 from the previous assignment. So again, the first part of your homework was to go ahead and just factor it using the pattern we talked about for the cubes. So this time we have 8x to the 3rd minus 1. When you factor that using the sum or difference of cubes, you should have ended up with 2x minus 1. And then we have 4x squared plus 2x plus 1. All right, so just like the last one, this first factor here, we can go ahead, get this out of the way right away. 2x minus 1 equals 0. Okay, and we can get a solution by solving this. So I'm going to add 1 to the other side. So 2x equals 1. Divide both sides by 2. X equals 1/2. Okay, so this would give me a real solution. Okay, it is a fraction, but it is still a real solution. All right, now we have to try to factor this part. And again, you can take a look at it. Maybe you try to factor it using your other methods, but this is not factorable. I know that. So let's go ahead and do our quadratic formula. So again, A this time is going to be the 4, B is going to be the 2, C would be the 1. All right, so please take a look at your formula. You should have that in your notes or it's in your book. Look at the formula and plug your numbers in. All right, so we've got x equals, we need the opposite of B, so that's going to be -2 plus or minus, all right, and we b squared, so 2 squared minus 4 times a, which is 4, times c, which is 1. All right, all over 2 times a, which is 4. All right, I'm going to go ahead, I'm going to calculate the discriminant. So just in my calculator, I'm going to punch in just the numbers that are underneath the square root. So we have 2 squared minus 4 times 4 times 1. All right, so that gives me a -12. My denominator is 8. All right. Now again, if that's the answer you got, you did all the calculations correct. However, we don't really want to leave it like that. Again, you see that -12 underneath the square root. So I do expect you to simplify get that negative sign out from underneath there. That negative sign is your I, because the square root of -1 is I. All right. So we're going to leave our -2 there, plus or minus. I'm going to bring out the I. Okay, then I would have the 12 underneath, and denominator is 8. Okay. Now again, this one, 12 is a pretty small number. I do believe or hope we would know some perfect squares in 12. So again, I'm going to kind of go over here for a second. When I think of 12 and I think of perfect squares, I think of 4 times 3. 4 times 3 is 12. All right, 4 is a perfect square. So if I wanted to simplify this all the way to the end, we're going to have -2 plus or minus. The square root of 4 would be 2. So now I have 2i, and then I have my square root of 3 all over 8. Okay. And if I want to look at my fractions and again, make it look as good as possible, and again, just think of a fraction. Could you simplify, if you ignore everything else here, could you simplify a 2 over 8? Okay, 2 over 8 would be the same as 1 over 4. So I'm going to go ahead and write this as -1 plus or minus 1i square root of 3 over 4. Okay. When you check your answers in the back of the book, they will always have them in simplest form. Okay, so again, once you get to here, that means you did everything correctly as far as applying the formula, but you do want to simplify it. And like I said, if you look in the back of the book, they will always simplify it all the way down to the very end with the fractions and the radicals. All right, so for your homework, you're going to be taking the odd problems that you did previously, and you're going to finish them up, okay? Like I said, the first assignment you should have already factored, okay? So I would double check to make sure you factored correctly. So if what you did doesn't look like anything that I showed you here, you might wanna take a look at those notes again and make sure that you factored it using the pattern for the sum or difference of cubes. Again, the first factor, you go ahead and set equal to 0 to get your real solution. And then you'll have to apply the quadratic formula to that trinomial that you see there to get the two complex solutions. So again, your complex solutions will have the I in it. All right. Okay, well, good luck. And if you have any questions, again, feel free to send me a quick email.